Securing wires and boxes in a concrete house with styrofoam walls requires careful consideration of legal and safe practices. One method involves pre-cut channels. Cutting channels into the styrofoam using a hot knife or router is a legal method of securing wires and boxes. The channel should be deep enough to fit the wires and boxes snugly. Another option involves mounting plates. Mounting plates are designed to fit between the studs and the styrofoam. The wires can then be stapled or screwed to the mounting plates. For boxes, the expansion anchors can be used. Expansion anchors secure them directly to the concrete walls. Zip ties or cable clamps provide another securing method. Zip ties or cable clamps bundle wires together and secure them to the studs or framing members. When bidding the job, to avoid losing money on the job, consider the following factors. Firstly, material costs. Estimate the amount of concrete, styrofoam, rebar, and other materials required. Include the cost of delivery and any specialty items. Secondly, labor costs. Determine the number of hours required for the project, including excavation, foundation work, framing, installation of insulation, electrical wiring, and finishing. Consider the hourly rate of your employees and any subcontractors. Thirdly, equipment and rental. Factor in the cost of renting or purchasing equipment such as concrete mixers, power tools, and scaffolding. Fourthly, overhead costs. Include expenses such as insurance, office expenses, and administrative costs. Fifthly, market demand. Research the current market rates for similar projects in your area. Sixthly, negotiation. Be prepared to negotiate with potential contractors by offering discounts or incentives to secure the lowest bid while ensuring quality. Additional tips include: firstly, use weather-resistant electrical boxes to protect the wires from moisture. Secondly, fill any gaps around wires and boxes with expanding foam to prevent air infiltration. Thirdly, if possible, install wires horizontally to minimize the risk of water damage. Fourthly, have the electrical work inspected by a qualified electrician before closing the walls. When running electrical wiring in a concrete structure with styrofoam insulation, it's important to adhere to the National Electrical Code, or NEC, and local building codes to ensure safety and compliance. The NEC provides guidelines for wiring methods, conductor sizing, overcurrent protection, and grounding. For example, NEC Section 300.4 addresses protection against physical damage, requiring that conductors be protected where subject to physical damage. In the case of styrofoam insulation, this might mean using conduit or other protective measures to prevent the insulation from compromising the wiring. Consider the ampacity of the conductors used. The ampacity of a conductor is its current carrying capacity in amps. NEC Table 310.16 provides ampacity ratings for conductors based on their insulation type and temperature rating. Ensure that the conductors selected are appropriately sized for the intended load and that the overcurrent protection, such as circuit breakers or fuses, is sized accordingly. When installing electrical boxes, ensure that they are securely mounted and properly grounded. NEC Section 314.23 provides requirements for box mounting. For concrete walls, consider using concrete anchors or other suitable fasteners to securely attach the boxes. Grounding is crucial for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and preventing electrical shock hazards. NEC Section 250 provides detailed requirements for grounding and bonding. Ensure that all metal enclosures, such as electrical boxes and conduit, are properly grounded. When running conductors through styrofoam insulation, be mindful of the potential for heat buildup. Styrofoam is an insulator, which means it can trap heat. Overheating conductors can lead to insulation breakdown and fire hazards. To mitigate this risk, consider using dirting factors for conductors in insulated environments, as specified in NEC Table 310.13b2. Furthermore, ensure that the conductors are properly ventilated and not tightly packed within the insulation. Pay attention to voltage drop. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce energy efficiency. NEC Section 210.19 AM provides guidelines for voltage drop in branch circuits. To minimize voltage drop, use larger conductors or shorten the length of the circuit. When working with concrete, be aware of its corrosive properties. Concrete can corrode metal conduit and electrical boxes over time. To prevent corrosion, use corrosion-resistant materials such as PVC conduit or coated metal conduit. Also, consider applying a protective coating to the concrete surface to reduce its corrosive effects. In addition to the NEC, local building codes may impose additional requirements for electrical installations. Consult with the local building department to ensure compliance with all applicable codes and regulations. During the bidding process, consider all aspects of the project, including material costs, labor costs, equipment rental, and overhead expenses. Obtain accurate quotes for materials and equipment to ensure that the bid is competitive yet profitable. Accurately estimate the number of labor hours required for the project, taking into account the complexity of the installation and any potential challenges. Factor in overhead expenses such as insurance, permits, and transportation costs. Conduct thorough research on market rates for similar projects in the area. This will provide a benchmark for pricing the bid competitively. Be prepared to negotiate with potential contractors or clients. Offer discounts or incentives to secure the job while maintaining profitability. Document all assumptions, calculations, and quotes used in the bidding process. This will provide a clear audit trail and help to justify the bid if questioned. Also, clearly communicate the scope of work and any exclusions to avoid misunderstandings later on. When working with Styrofoam, consider the environmental impact and choose eco-friendly materials and practices whenever possible. Use recycled Styrofoam or other sustainable insulation materials. Properly dispose of Styrofoam waste to minimize its environmental footprint. Also, consider energy-efficient lighting and appliances to reduce energy consumption and promote sustainability. When installing electrical wiring in a concrete house with Styrofoam walls, safety should always be the top priority. Follow all applicable codes and regulations, use appropriate safety equipment, and work with qualified professionals to ensure safe and reliable electrical installation. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and hearing protection. Use properly insulated tools and equipment to prevent electrical shock hazards. Also, be aware of potential hazards such as dust, fumes, and noise, and take appropriate measures to mitigate these risks. If unfamiliar with any aspect of the electrical installation, seek guidance from a qualified electrician or electrical engineer. Also, consider attending training courses or workshops to enhance knowledge and skills in electrical safety and installation practices. In addition to the technical aspects of electrical wiring, consider the aesthetic aspects as well. Conceal wiring and electrical boxes whenever possible to create a clean and uncluttered appearance. Use decorative cover plates and fixtures to enhance the visual appeal of the electrical installation. Also, consider the placement of outlets and switches to ensure they are conveniently located and easily accessible. When installing electrical wiring in a concrete house with Styrofoam walls, meticulous planning and attention to detail are essential. Take the time to thoroughly assess the project requirements, develop a comprehensive plan, and execute the work with precision and care. This will result in a safe, reliable, and aesthetically pleasing electrical installation that meets the needs of the occupants and enhances the value of the property. Remember to document all aspects of the electrical installation, including wiring diagrams, equipment specifications, and inspection reports. This documentation will be valuable for future maintenance, repairs, and upgrades. Also, retain copies of all permits and approvals to demonstrate compliance with applicable codes and regulations. When working with electricity, it's always better to be safe than sorry. If there is any doubt about any aspect of the electrical installation, seek guidance from a qualified professional. Electricity can be dangerous if not handled properly, and mistakes can have serious consequences. By following best practices and prioritizing safety, you can ensure a successful and rewarding electrical installation project. Also, consider the future needs of the occupants when designing the electrical system. Anticipate potential future loads, such as additional appliances or electronic devices, and provide adequate capacity to accommodate these loads. Consider installing additional outlets and circuits to avoid overloading existing circuits. Also, consider incorporating smart home technology such as smart lighting, thermostats, and security systems to enhance convenience, energy efficiency, and security. Remember to properly label all circuits and electrical panels to facilitate future troubleshooting and maintenance. Use clear and legible labels to identify the purpose of each circuit and the location of the corresponding outlets and switches. Also, provide a detailed electrical panel directory that includes circuit breaker assignments and other relevant information. When installing electrical wiring in a concrete house with styrofoam walls, be mindful of the potential for moisture accumulation. Moisture can damage electrical components and create shock hazards. To prevent moisture problems, ensure that all electrical boxes and conduits are properly sealed to prevent water intrusion. Also, consider using moisture-resistant wiring and electrical components in areas prone to moisture exposure. When working with concrete, be aware of the potential for alkali-silica reaction, or ASR. ASR is a chemical reaction that can occur between the alkaline cement and certain types of aggregates in concrete. ASR can cause cracking, expansion, and deterioration of the concrete. To prevent ASR, use low alkali cement and non-reactive aggregates. Also, consider using chemical admixtures that inhibit ASR. When installing electrical wiring in a concrete house with styrofoam walls, consider the impact on indoor air quality. Styrofoam can emit volatile organic compounds, or VOCs, which can negatively impact indoor air quality. To minimize VOC emissions, choose low VOC styrofoam products. Also, ensure that the building is properly ventilated to remove VOC and other indoor air pollutants. Remember to comply with all applicable environmental regulations when handling and disposing of styrofoam and other construction materials. Dispose of waste materials properly to minimize environmental impact. Also, consider using sustainable building practices to reduce the environmental footprint of the construction project. When installing electrical wiring in a concrete house with styrofoam walls, continuous learning and professional development are essential. Stay up to date on the latest codes, regulations, and technologies in the electrical industry. Attend training courses, workshops, and conferences to enhance knowledge and skills. Also, consider pursuing professional certifications to demonstrate competency and expertise. Remember to maintain a strong commitment to ethical conduct and professional responsibility. Always act with integrity and honesty in all business dealings. Provide accurate and reliable information to clients and colleagues. Also, respect the rights and opinions of others and treat everyone with courtesy and respect. When installing electrical wiring in a concrete house with styrofoam walls, consider the long-term durability and maintainability of the electrical system. Choose high-quality materials and components that are designed to withstand the rigors of the environment. Install wiring and equipment in a manner that facilitates future maintenance and repairs. Also, provide adequate access to electrical panels and other critical components. Remember to document all maintenance and repairs performed on the electrical system. Keep records of all inspections, tests, and repairs. Also, maintain a schedule for routine maintenance to ensure the electrical system remains in good working order. When installing electrical wiring in a concrete house with styrofoam walls, consider the impact on the overall energy efficiency of the building. Choose energy-efficient lighting and appliances. Install occupancy sensors and timers to reduce energy waste. Also, consider incorporating renewable energy sources, such as solar panels, to generate electricity on site. Remember to conduct a thorough energy audit of the building to identify areas for improvement. Analyze energy consumption patterns and identify opportunities to reduce energy waste. Also, consider implementing energy-efficient building practices to reduce the overall energy footprint of the building. When installing electrical wiring in a concrete house with styrofoam walls, remember that collaboration and communication are key to a successful project. Work closely with architects, engineers, contractors, and other stakeholders to ensure that the electrical system is properly integrated into the overall building design. Communicate effectively with all team members to ensure that everyone is on the same page and that any issues are addressed promptly. Also, be open to feedback and suggestions from others. Listen carefully to their concerns and perspectives and be willing to compromise when necessary.